Hello and welcome to the second video in a series of videos on partial derivatives. Isa lang yung objective natin for this video, and that is to calculate partial derivatives using techniques of differentiation. So last video, define natin what partial derivatives are and also we also discussed how to calculate them using the limit definition. Pero bago tayo magpatuloy, let's just recall. So given a function y equal to f of x, so function of one variable, yung derivative niya, that's dy over dx. This is just the limit of delta y over delta x as delta x goes to 0. Tapos define natin yung mga partial derivatives in the same way, right? So yung, halimbawa, yung partial derivative with respect to x, that's the limit of delta z over delta x. So change in z over change of x as the change in x goes to 0, right? This is the change in x in this case. And similarly, for the partial derivative with respect to y, ito yung definition natin. So, baka naisip nyo, kasi parang magkamukha itong dalawang limit na to. So, baka naisip nyo yung notation na ganito, bakit di natin gamitin, na parang dz over dx. Okay? Actually, hindi yan ginagamit, pero merong ginagamit na medyo kamukha. So, ito yung gusto ko ipakita ngayon. Okay? So, we have other notations for the partial derivative. For f sub x, ginagamit natin yung notation na to. So, these are curly d's. So, mga d's lang rin yan, pero they are rounded. Okay? Pero ang basa natin dyan ay partial. So, this expression here is read as partial z over partial x. So, ang ibig sabihin, kinuha mo yung partial derivative of z with respect to x. Okay? And kasi yung z natin sa example na to, that's f of xy. So, pwede mo rin siyang isulat as partial f over partial x. Okay? At kung gusto mo, parang ganito na. Kinuha mo yung partial derivative ng f of xy. So, pag tinignan mo tong symbol na to, you should think of that as an operation. No? Kinukuha mo yung partial derivative with respect to x nung function na to, f of xy. Okay? Itong operator na to, minsan tinatawag rin siyang d sub x. So ito yung Newton notation. Okay? So kinukuha mo yung partial derivative ng f of xy with respect to x. At syempre, kung meron yung mga notation for fx, meron din corresponding notations for f sub y. So parehas lang. Okay. So balik tayo dun sa tanong natin kanina. Actually, hindi ko pa yung tatanong na. Pero nung kinocompute natin yung partial derivatives, we were using the limit definition. Ayaw naman natin na laging ganun mag-compute na. So is there an easier way of calculating partial derivatives? And syempre, yung sagot natin dyan ay yes. Okay. And I will tell you now how to do that. Basically, if you want to calculate the partial derivative with respect to x, so unahin mo natin yung with respect to x. Okay. Gagawin nyo lang, you will have to treat y as a constant. So lahat ng makikita nyong y, isipin nyo constant lang yan. So now, you only have a function of x. Okay? So because you now have a function of x, you can just differentiate that normally with respect to x. And that's whatever you get from that process will be the partial derivative with respect to x. Okay? Similarly, if you want to get the partial derivative with respect to y, so y yung variable natin, y yung gumagalaw, yung x natin, you will just have to treat that as a constant. Okay, and then just differentiate with respect to y. Ba't siya gumagana? Let's see. Halimbawa, pag finix mo yung y, so hindi gumagalaw yung y, we're treating y here as a constant. Tapos define natin yung function g of x. It's f of xy. So yung value niya at x is given by f of x, comma, this fixed value of y. Okay? So ano yung derivative ng function na to? So by definition, this is the limit of g of x plus delta x minus g of x all over delta x as delta x goes to 0. Yan lang yung definition natin ng derivative, right? Pero because of the definition of g, this is just the same as the limit of f of x plus delta x comma y minus f of xy all over delta x as delta x goes to 0. And this is, of course, precisely the definition of f sub x. So kaya siya gumagana. If you want to get the partial derivative of f with respect to x, gawin mo lang, i-consider mo yung function g, which is the function that where you assume that y is a constant. Okay, and then differentiate that normally. All right? So halimbawa, balikan natin yung example natin from last time na kinuha natin yung partial derivatives ng f of xy equals 2x squared y minus 4y using the limit definition. Ngayon naman, gamitin natin using the techniques of differentiation. So for fx, gusto natin kunin yung, ito ginagamit ko na dito yung notation natin. So again, yung notation natin for partial is not d, but a rounded d. So kinuha natin yung partial derivative with respect to x of 2x squared y minus 4y. Ngayon sabi natin sa remark, we have to treat every y as a constant. So ano yung mga constant natin dito? So 2 is a constant, y is a constant, and negative 4y, lahat yan, they are constants. Okay? So paano mag-differentiate ng constant times x squared, halimbawa, so for the first one, constant times x squared, that's going to be the constant, okay, this is the constant, times the derivative of x squared. Okay. Tapos, anong derivative ng constant? Ang derivative ng constant ay 0. So, magiging 0 lang. Right? Tapos, yung derivative, of course, ng x squared is equal to 2x. So, this is just 4xy. Tapos, ito rin nakuha natin kanina or dun sa isang video na. And similarly, kapag kinatin yung partial derivative with respect to y, you have to treat here your x as a constant. So dito sa case na to, yung 2x squared y, ito na yung constant natin. Tapos itong negative 4, syempre constant din yan. So paano mag-differentiate ng constant times y? Okay, so this is a constant times y. So equal siya sa constant times the derivative of y. Di ba? Tapos yung second term, so paano i-differentiate? So that's gonna be negative 4 times the derivative of y. Okay? And of course, the derivative of y is just 1. So this is just 2x squared minus 4. And again, that's the same function that we obtained using the limit definition. Okay? So here's another example. Let's try to calculate the partial derivative of this function, sine squared of 2x minus 3y, with respect to y. So with respect to y, ibig sabihin yung x natin here is just a constant. You should just think of your x as a constant. So ang ibig sabihin ng sine squared, remember, is you're squaring the whole quantity, yung buong sine of 2x minus 3y. Ini-square natin yan. So you have to use your chain rule kasi you're differentiating something squared. Ang derivative ng something squared is 2 times the derivative 2 times something, kung ano may nasa loob, times the derivative of the inside function. So ano yung derivative ng inside function? Ano yung derivative ng sine of 2x minus 3y? So that's gonna be cosine of 2x minus 3y times, again, kunin mo yung derivative nung nasa loob. Pero as I mentioned earlier, you have to think of x as a constant. Okay, so pag differentiate niyo yung constant minus 3y, okay, that's gonna be 0, right? Kasi derivative ng constant ay 0, minus 3. So ito na yung final answer natin. Negative 6 times sine of 2x minus 3y times cosine of 2x minus 3y. Okay. So sa video na to, isa lang yung objective natin, and that was to calculate partial derivatives using techniques of differentiation. And the way that we can do this is to treat the other variable as a constant and differentiate normally.